if you talk to people and you say, how secure is your system? Right? Do you get security? And people go, yeah, we have a fantastic secure system. Nobody can get in. And you tell that to the world. It's a big, strong castle. Nobody could ever break in. But actually, you know it's a bit more like this. Right? It's not as secure as you might let on, but it doesn't matter. But the reality is that even you are too optimistic. And the reality is, this is how secure your system is, right? I know it's jokey, but as I'll show, it really can be this bad, right? And if we don't fix this, this is what your system's going to look like. Broken, dilapidated, never used, okay? It's bad. It's so bad. Recently, something really bad happened. It's happened before, but it happened sort of the biggest ever. For many people in the world, a few weeks ago, a few days ago, the internet stopped. It really did, right? There's this company called DYN, and they provide them probably a very large part of the DNS lookup thing. So you know, you're putting something on the web, you type in a URL, you know conceptually that URL gets turned into an IP address and magic happens, right? And maybe you know more about it than that, but you've got that relationship. Somebody has to do the table looking up. And you've probably heard about DNS and about there being all sorts of things going on, but at the end of the day, somebody runs that. And if that DNS service is targeted with what's called a DDoS, distributed denial of service attack, that's when you get lots of computers asking another computer to do something or respond so much that no legitimate traffic can get in, right? This is the largest ever. Tens of millions of IP, tens of millions of devices were pointing at DNSs run by this company, right? Enormous amounts of data. The net was, for a large number of people, the internet stopped, right? Various groups have claimed responsibility. We don't know. It could be a criminal activity, it could be a cyber warfare thing. There were things about the pattern that suggested that maybe it was being used as a sort of a calibration exercise, but it's possible, you can imagine, if this is your system, that you could be being held to ransom because people won't let, you've got people trying to prevent others getting to your website, right? So this is horrible, but I'm not going to talk too much about this, right? Although I will show you, this is from Wikipedia. This is the list, some of the companies that got hit by that. So you can see what got me was Box was down, GitHub was down, PayPal, what else? Slack, use Slack a lot, Twitter, and these are just some, right? And so a lot of people, it was down, right? Imagine if your company's up on that list, right? The point being that the way this was achieved was by a thing called a botnet. Lots of machines taken over by the bad guys, who we'll talk about, and that machine is now redirected to do new things. And I'll talk about here, and I'll talk about it a bit later on, but look at what I say about the types of things that were in this botnet. This is where it starts to get scary. So you've got printers, you've got IP cameras, you just got your little gateways, right? You've got baby monitors. Of course, you've got your usual sorts of stuff, but all of these devices are out there and they're being sold, and most of these smaller devices come with what's called a system on a chip. How many people here have got a Raspberry Pi? Okay, not enough, not enough. A Raspberry Pi is a thing called a system on a chip. All the heavy lifting is done by a piece on a chip, and there's I/O stuff around the outside. You don't have to have the I/O. You can have the system on the chip, runs Linux, or something similar. You embed it in your smart TV. Okay? You plug your TV into the network. Okay? And now your smart TV, if your network's compromised, then it could be discovered. If you plugged it on the public web, then it's going to get found pretty quickly. These things do horrible things to other people's systems, and they're in your house. The thing to think about is they also take up, what happens to them is affecting you. So medical equipment, think about this. How about these guys running in a hospital, and they're running some of the important medical equipment, but now they're being subsumed to do other things. And that means the CPU is being used, that's being used is, you can't use it for what it's intended to happen, right? So whoever did this, whatever reason, the main thing to point out is, much as we think the internet is this box over there, and we have our stuff here, it isn't like that at all. You have to basically treat the whole of the internet and your local networks, wherever you are, as flawed, as open, as anything you plug into it might be discovered and used against you, right? So it gives you this Internet of Things. So everybody's heard of the Internet of Things. It's this fantastic thing where every little device gets connected. Well, as we're showing, the problem with Internet of Things at the moment is it's not very secure. In fact, somebody made a joke about it. The S in IoT stands for security, right? And you go, this is really funny. I like this, right? No, I have colleagues who work in IoT, and I do things with it, and I go out and talk about IoT, and we go, okay. But the problem is this. There's no S in developer either, right? As developers, we ignore security. So that's why I'm saying this isn't to talk about you going off and creating secure Java applications. Before you get there, you've got to learn about how to build and deploy them securely and understand the place you're playing in, right? So, okay, so I talked about the thing on DYA and bringing them down. Let's put some money around this. Let's try to make this even scarier for you. So, cybercrime realities. And I'll give you the numbers in a minute, but organized cybercrime is the most profitable type of crime, right? And we'll talk about that, right? 80% of cyber attacks are driven by organized crime rings. Here's the big thing, right? It's not about hackers anymore. It's about people out for profit, which is why things like the D1S attack is worrisome, because not only they got a bot they can do things with, denial of service attacks, they're hard to defend against. They're not impossible, but they're hard to defend against. And they could be pointed at your company, and you could be held to ransom until it goes away. Cybercrime is estimated this year, the figures are $445 billion, right? In 2013, a data I have is the whole of the drugs trade, the illicit drugs trade, was 435. So this year, it's more than the drugs trade. And the expectation is actually the drugs trade hasn't gone up that much. Cybercrime is basically the most profitable way of making money illegally there is, right? It has the least risk to the criminal. They never get caught for cybercrime, right? It's growing like anything, right? The expectation is $2,100 billion by 2019, right? It's an enormous business. And I want you to think about what you know about the drugs trade and the videos and movies you've seen and the amount of effort that people put into that, right? It's slowly moving this way. Right? There are so many places where they're coming in. They're stealing data records all the time, right? You may think your data records are secure wherever you put them. Believe me, people are out to get them, right? So many million devices, but they've all got mobile phones, okay? A good chunk of these are compromised, right? Not that you know about it, because the aim is not to make you aware of it. The aim is to use your device to do something else. The last thing they want you to know is that your device is being used as part of a botnet. Right? What can I say? This is real. This is a hugely scary problem. We have an internet that's got lots of flaws in it, and we have people out to make money out of that fact. And as developers, we're generally ignorant. Okay? So let's talk about the data they're going to get from you. Okay. So I said they're not doing cyber graffiti anymore. These guys aren't taking your website and saying we were here on it. That's not what they want. They want to steal your data, and they want to do it quietly. And they're going to come into your system over and over again and steal your data. Right? Whatever type of system mechanism they use, we could talk about all sorts of ways of doing it. They're basically going, if I can get some data from you, I can make money, right? And the more money I get from you, the more insight I get from you, the more money I can make, right? Because if I know about you, I can do some social engineering attacks on you, right? It's your facts. All your data is valuable, right? It amazes me how developers, you may be very good at writing code, but you're very trusting, right? And you go, oh, reuse passwords and do things like that. You do the wrong things, and we just don't talk about it, right? These guys, they want everything. If I can get some information about you, I can sell it. If I can get your credit cards, I can sell you. If I can get your date of birth, right, and your name, if I can connect things together, I can find out, probably, I can go to something like Ancestry.com, and I can find out where you were born, maybe who your mother was. So there's those questions that you have for the banking that says mother's maiden name, and you put it in because you'd remember it. Well, it's actually public knowledge, right? So I've now got that. And it's the same with other things, right? There's a lot of effort going on about that. They want to know what you think about the people you work with. I want to know what websites you visited. I'm building a profile up for you because I'm going to craft an attack against you personally, right? Now, you've seen some of these before. You've probably had those fantastic emails that come through and say, your ATM card of this is good, I can see it down here. Your ATM card of $10 million was returned by a courier, blah, 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 and you go, yeah, spam, delete, okay. Oh, it's got Nigeria in, so bank, okay. And then you get, I got this one, Federal Bureau of Investigation, blah, 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 where it says, past corrupt government officials who almost held the fund to themselves for their selfish reason. Okay, yeah, the FBI is going to do that, and tell me all about that. So, yeah, spam, okay. I got this one too. You have won a brand new BMW Hydrogen 7 Series car, which I don't know if it exists, a check for $500,000, and an Apple laptop, which is obviously worth more than the other two, right? Right? And you go, yeah, spam, okay? You don't fall for those, no, okay. How about something like this? Suppose that you got a boss who you don't get on with very well, or you're a bit frightened of, okay, and you're involved in some discussion, and you get an email saying, I've spoken to them, or you get a text, I've spoken to them, here's the details, just go pay it. I'm off, don't bother me, right? This is social engineering. This is what people will do. And they find out that you don't like your boss because they went to Facebook to see what you said. And they connect those things together, right? Okay? You have to be starting to think that they're out to get you, right? Okay. I want you to be paranoid. No. Okay. You think all the bad guys are stupid? No, because, well, we'll come on to why that's not true. So, a couple of other instances. This is real. This is not aimed at developers. This is aimed at guys in the transport industry. Some knowledgeable people who are knowledgeable in the IT industry, okay, and knowledgeable in the business industry, targeted non-savvy IT people. They found people really busy and they targeted them, right, because they knew more about IT and about the business. And these guys got this wage and they end up paying it, okay? More, right? Email instructions to victims to download an Android or app. Blah, blah, blah. I accept it. It goes on my phone. I know nothing about it. But the application that I've installed is now tracking that I've got these, that I'm sending out bank transaction codes through text, right? Which is probably a bad thing to do, but that's what was going on. And socially engineered, targeted the person, got them to accept it, okay? So it's becoming more about moving from this global, let me try and hit anything, to more focused things. And I want you to think about this bit, right? When you saw those original spams, and we've all got them, I get them all the time, and you laugh and shut them away, right? They're aimed to find the gullible people. Why would I try and find the most intelligent, suspicious person to perform my tricks on? No, I want the least capable person, the person who's going to be the most gullible. So if I'm blanketing the world looking at ways to steal a few $1,000s in somebody, I just blanket the world and I'll get a few, okay? And great. But when I'm targeting you, I'm not going to do that because I know you're not going to fall for it. But I'm going to socially engineer attacks on you as individuals and companies, right, to make you do what I want you to do, right? So who are they targeting? So they're targeting the middle-level execs. That's quite a common one. People who are not very happy with their VP, a bit worried. They're being targeted, as you'd expect. New people. You've just joined the company. Okay, you've said, hey, Facebook, I've just been in this company. It's brand new. It's fantastic. You get an email, right? So I'll give an example of that. Not quite connected, but recently I got an email that's within internal IBM. I got an email and it said, your laptop is up for refreshment. And it was very legitimate. And it said, 4-year thing, blah, 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 click here. Now I know, because I'm inside IBM, what the program is for refreshing these laptops. And I went, and then I went, no, the URL's wrong. So they failed at the last hurdle. But if that had gone to somebody brand new, and I'm sure it would, who didn't understand, they'd see this email and go, yeah, okay, press the button, right? So they're looking for those. They're looking for the people who are really busy and just don't have time for this. Disgruntled employees, the usuals. This is the people who they'll approach and say, we'll pay you, you let us in. And then they're after you guys, right? You are the golden goose, right? The bad guys prey on the weak, vulnerable, and ignorant, right? That's you. Sorry, from this point of view, that's you. Well, why is that? Well, we're too trusting. We know how systems work. We write the code, right? We have root privileges, right? And we're over-trusting, and I'll talk about over-trusting in a minute. But you use other people's code, right? How many here have you ever gone and said, oh, I've got my Maven project or my Gradles or whatever, and I've gone, I've Googled about a problem, there's a piece of code that will fix it, it's in this package, I'll just go to my manifest and I'll include it, right? You didn't even check. If you're really lucky, maybe you checked. Maybe you have a policy about checking the license for the piece of software you're going to consume. But I bet you have no thought about whether you can prove whether that software contains any malware or vulnerabilities, or whether the person, the individuals who are providing it, whether or not they are telling you how they deal with vulnerabilities, because nobody does, right? We're just totally ignorant of this, right? And let me give you some examples, right? So I'm including myself in here, right? This isn't me saying you guys are awful and I'm fantastic. I've made all these mistakes and more, right? So how about these? How many people have ever done something like this? Getting Java to accept all certificates over HTTPS. Yeah. How do I trust any SSL certificate? Yeah, okay. How about very trusting trust manager? Yes. How do I disable certificate validation in Java? Why would you be Googling for this? Well, you're Googling for this because you've got a circumstance and it's easier to turn that off than to understand what you have to do to fix the problem, right? Have you ever written anything like this? This is the ever trusting trust manager. Is client trusted? True, right? Is server trusted? True, right? But this is real code, right? People do this all the time, okay? And they go worse. Tooling. If you use curl or wget, you might have said, don't, turn off all the checking, because one of the servers you're targeting has got self-signed certificates and it's causing you a problem, right? Or maybe you do even worse, sudo apt-get allow unauthenticated, right? We've all done that, right? We do it all the time, right? We all know the whole world, but the whole world does it, so therefore it's okay, right? So I did a search for implement trust manager on GitHub. Here's a few examples. 76,000 hits. Now, admittedly, it's all the words, but here things, the over-trusting trust provider, a very trusting trust manager that accepts anything, right? Okay. And this is in code on GitHub, right? It's okay, is it? No, it's not okay, right? You guys are just too trusting. Beginning of the year, March I think it was, you may have seen there's a little JavaScript thing where one of the guys who was providing an NPM package withdrew it. And he withdrew it because there was some argument going on. I didn't know you could do that. Probably the rest of the world didn't. And he withdrew it. And the consequence was that a lot of JavaScript things failed. Right? Now it failed. Okay, so what do? They fixed it. Well, in fact, the NPM guys, I think, put something back. My point is that that was a package that everybody was using and nobody knew about it. And this guy obviously had complete access to put whatever he wanted in there. Right? So if he had been somebody who had decided he wanted to do something bad or not very good at security code, or he'd have been hacked, all the JavaScript guys could have suddenly found themselves running some compromised software. Right? And they'd never know. Right? So, and it's the same with things like Maven repositories, Docker, Linux repos. We don't check. Right? We're really crap at doing anything that says, how do I prove that thing is good? Partly because you don't know what to do to go check, right? But at the very least, you're not even in that mindset, right? You paying attention? This is what's going to be. So, who are the bad guys? Not these. This is just a picture I borrowed from Flickr. You can see they are obviously the bad guys, right? So, things to know about them is they're you. Most of the guys who we know about are ones that didn't start off as developers, but started off as basically as criminals doing something else and got the IT bug because they could see the money they could make and they got into it, right? But they follow. The chances are there might be one or two of them in this room now. You know, you don't know. The chances are that they're out learning Agile and DevOps and Java, you know, and technical things because they're writing this code and they want to understand how you write your code as well, right? Highly experienced, highly motivated, lots of money, right? Innovating, sharing. They have a fantastic community for sharing stuff, though they charge you for it. But it is this out there, all right? Anything you want to know you want to find some way of hacking some system? Fine, easy, right? I don't know how they know the average age is 35, but there we go. So a couple of quotes. I'll let you read it, but basically what we're saying is we know that the majority of cyber criminals that get arrested, they're arrested because they were doing something else. They were still doing their old job, so to speak, and they got caught for peddling drugs or fraud or whatever. And it's because of that we found out they were into IT crime. And it's just, well, what can I say? It's horrific. So, what else am I going to tell you? Expanding the attack vector. Yeah, so how do they get in? So I told you about social engineering, which we've already talked about. That's really good. That's getting you to say, come in and steal my sofa. Please, it's lovely. Vulnerability exploits. Now, this is the big one. This is the big technical problem. And then inside information, which is where you sell it. There's very little you can do about that except have some very draconian internal processes for managing things. You could still do something, but let's look at the one in the middle, right? Let's look at vulnerabilities. Every piece of software you use has vulnerabilities. Vulnerabilities isn't a smoking gun. It doesn't say, get in here the sneaky way. There's no comments that says this is the thing you do. Vulnerabilities are little things. And they're just things you may not have realized that you've done, and they get combined together. So as an example, there's Heartbleed and Shell Shock, and you've probably heard of a few of these bugs floating around, big vulnerabilities. But which one is it? Heartbleed. Heartbleed is the one where a little call gets made to your server, and it says, give me back some data. And in theory, all it should ever ask for is 4 bytes. But if it asks for more than 4 bytes, you get this buffer overrun, and it says, the piece of code that you're running, if you're vulnerable, says, I'll give you back whatever you asked me for. So if you ask me for 2K, I'll give you 2K of memory. If I do that enough, I pick up a copy of your memory, your running application memory. And because I know how your code works, and I've got other tools, I can figure out what the memory pattern is. I can find the passwords. I can find the important bits of data, right? And once I've got that, then I can come back in. And so that's why Heartbleed and these others are so horrific, because you may think, oh, what a big deal. But it's like, no. Persistence, combining them together, that's the classic 2 or 3 vulnerabilities combined together, give you the bad guys access, right? And there are loads. You can go to this site, cve.mitre.org, and you can put in some search criteria. These are lists of vulnerabilities that have been reported. These lists are, it's probably a year old now. This one is for, I don't know which is which. That's Java. One was XML, I think. No, one was JavaScript. Oh, JavaScript, Java, and serialization. But go search what you want. Right? Don't be frightened by the number you find, because they're there. There are just loads of them. Right? And there are even more. Here's some more URLs if you're interested. It's a different website, but there's lots of them. You can go to, there are lots of information about there for you to understand about vulnerabilities. Right? One I should point out is the Apache Maven one reported. That was a nice little vulnerability that meant SSL checking was turned off by default in that particular version. Right? It just happens. You're using code and it's not doing what you expect. So it's these things put together that makes that happen. And what we've got to do, right, the way that we're going to deal with this is not so much about code engineering, but that's important. You've got to start thinking about how you would engineer safe code. And that's an enormous talk on its own. And I would suggest that you go to Google for secure Java frameworks and secure Java engineering. There's lots of good advice, but it's massive. So we need to focus on the first bit, which is not having, so 0 days. Has anybody heard 0 day exploits? You would get that? So yeah, so that's, I think you're the only one. So 0 day exploit is basically you're going, it's not old, right? The target of a vulnerability, if it's out, like those cameras I was talking about, if you've got a software, if you've got a system on a chip in a camera and it's installed in your house, it's never going to get updated. And any vulnerabilities on that are going to be there forever, right? So once they get discovered, they get shared. So what we want to do is get to the points where the bad guys have to rely on the newest ones that are coming out, the ones that they've got to engineer solutions for. We don't want them making use of the old ones. We want them having to work hard to catch the new ones, right? So that means you've got to keep your software up to date all the time. And we don't like that. Businesses don't like that. If you work in a bank, they'll say, oh, you don't do that. That's bad. That introduces risks. And what we're not very good at is going back to these guys and explaining to them what risk they're taking the other way, right? So you need to be thinking, what are you doing as you create your applications, wherever you work, to ensure that your application is up to date all the time? So it's not just OS levels, it's any piece of software that you use, anything you depend on, you've got to be going, what am I doing? How quickly can I get the next version installed? Right? When it comes out, how quickly can you do it? And we want that so that the bad guys go off and they attack the people who haven't done that, right? Because there's always going to be some. The good news is that the DevOps space has a lot of the technology to make this easy for you. You can use, Docker's a great one, but you can use VM images. So in the cloud space, you're talking about industrial creation and deployment of systems. And part of that is I've got to create an image of some OS, and I'm going to apply changes to it, and I'm then going to bundle up and ship it. So the DevOps stuff is where you need to start looking and understanding. So Docker, Puppet, Chef, Ansible, you start looking at those tools and getting your head around them so that you can start to build and influence the people who are building the deployment solutions that you're using. Right? If you use Jenkins to build these things, that's great. The point being, whatever you use, you want to start codifying it in so that you can press the button, get an application that's running the latest stuff without you having to put lots of effort into it. So, what have we got here? So I talked about devices. There's the ones, most of this is because they got default passwords. That gets you in. but there are others. Drive-by gateways, I'll demonstrate one of those in a second. Ransomware, that's easy. I'll encrypt your data. Yeah, I get into your system, I encrypt your data, and then you'll pay me in Amazon vouchers or something so that I'll decrypt the data for you or give you the key back. Right, there's lots of stuff in malware, blackmail. There's also places where it gets in which you might not have realized. Now, this is not as prevalent, but helpful stuff. You guys are helpful. You like helpful people. So if somebody does, how many people here use Docker? Good. Docker. Good, okay. Okay, more hands than Java 1, so think yourself praise. That's really good. So Docker, you go to Docker Hub, you see something, you download it, you install it. Right? That's bad enough because you should be going, what should I check before I download it? Have I got a Docker file with it? Can I reproduce it myself? If you can't reproduce it yourself, be worried, because maybe they're hiding something. If you have a Docker file, a Docker image that tells you to mount a volume, then you don't want to do that either, because Docker runs under root, and if you give it access to your file system, you've let untrusted, unknowable code access to your system, right? But it's free and it's helpful, you know, right? Paid stuff, if you pay for it, it must be okay. Games trainers, they're really good. So you're running your favorite game on your PC, and you can't win, so you buy something to help you cheat, right? Lots of those, and you down one of those, and your antivirus says, no, it does some bad things. But the deck says the information to go with this thing may trigger antivirus. It's okay. You go, yes, that's fine. I'm solving my problem. This guy has done it for me. I paid him some money. How bad can it be, right? All the time. Source injections. I can't remember, it was Ocean's 11 or 12. There was this great bit where they have to get the movie, where they have to get the dice modified. I don't know if you remember that bit. It's in one of the movies. And to do that, they went back to the source. They went back to the place where the dice are manufactured, and they inserted their malware. One of the things that people are trying to do is get into your GitHub repository and put some changes in, right? You'd be surprised at how many people would let that happen and not spot it, right? If I can get it into the source, if I can get it into the firmware of the system on a chip, then every IP camera that comes out would have my changes in. That'd be great, wouldn't it? Right? So pull requests that come in from other people, what do you do to vet them? Do you go, oh, it's a great thing, thank you? No. You should be looking at the person. Do you trust the person? Is the person making the pull request the person you expected? You know, how would you know? Right? And a lot of this is there's no technology. It's just you having a relationship that you can build up, that you can trust, and you can spot things. So if you have people who are unknown coming up, I did that grunt work for you. I did those mergings for you. I did some work, and you just take it. If you've ever used Git, and you did Git merges, you've probably not thought too much about the fact that that's an opportunity to insert different code. Normally a Git merge is take this change and this change, bring them together. But if the person doing that takes as an opportunity to give you as the committer some changes that you weren't expecting, do you check them? Probably not, right? So, let's rattle on. What have I got else to say here? Yeah, the only thing, I think most of these, default passwords are just evil. Just change them, have a policy, go around and beat people up, just change them, right? Just change them everywhere. They're just wrong. How many have passwords that everybody knows? Yeah. Build and test systems. What's the password to get on that build machine? Oh, it's this. It may be written on a piece of paper stuck on the wall, right? It's a bad habit, right? And as for your passwords, well, if you, I don't know what to say passwords, don't use them, use keys where you can. However, many websites have rules that make it really hard for you to use passwords in the best manner, and so you have to live with it. You should use some sort of password safe, you know, we all know that, right? I'm not telling you anything new, right? By the way, it's worth visiting Wikipedia so that you understand what makes a good password, right? And it's not necessary because you've got strange characters. Length is important by the characteristics. If you have a common password or a short password, the chances are I can get that hacked within milliseconds, because the hashes behind all these passwords tend to get sold. So when you see people breaking into sites and stealing information, they're probably stealing the hashes for things. Once I got the hash for your password, the encrypted form, I just apply compute power and I can break it, right? Once I've broken it, I've got the password and I get back in your system. Really easy. All right. So I said I'd talk about Wi-Fi gateways. Wow. How many people here are connected to the local Wi-Fi? Oh, actually twice because I've got two machines. Yes? Okay, right. They're everywhere, right? How do you know that that SSID that you've connected to is provided by the people who say they've provided the SSID? You don't, right? So you just see them. You see them everywhere, right? When Heathrow Airport coming out, there was like a long list of SSIDs. And I go, what are they? I'm going to connect to the one that I saw. So they're just everywhere. What can I say? And the problem is, apart from can you trust it in the first place, is that they tend to have things that will make you trust them because you see common untrusted scenarios. So you get, Safari can't verify the identity. And you go, yeah, that's because it's on a new Wi-Fi, accept, right? Right? It's a habit, right? So what happens if you're walking around and you spotted a white device like this, a little box? I've got one. Didn't bring it with me. Wasn't sure how it was going to go through customs. But you can imagine, there could be one of these on the side of the wall under your table, anywhere. USB power supply, so it's got a battery, Pi, a Wi-Fi dongle, right? Very easy. I can provide an SSID that you're going to use, because I can go outside and I can find the SSID and the password. Every conference that I've ever been on does that. Big or little, everybody does that. And if I didn't know, I'm sure I could find a free one, right? I can get you. And to make it worse, Wi-Fi protocols, there are things you can do to get you to come off the legitimate one and come to mine, right? Nothing you can do about it, right? And it's so easy, so I can spoof you. For some reason, people think that they go to a conference like this and they'll see a Wi-Fi or they'll go, that's fine. Why do you think that? Right? What is it about this place that means that you feel you can trust that? Because that's what you've got to start thinking about and we've got to start changing. Right? Coffee shops, Starbucks, wherever, you can go and connect to these Wi-Fis, right? And you have no idea whether it's been provided by the people that say they are. Right? And once you get in, well, I can take you. So I'll try and go through this quickly. So bear with me. So picture you, happy face, your browser, the internet, the gateway, and the website, right? Very simplistic. HTTP thing, give me data, goes through the router, out to the website, you get data back. Ta-da, easy. How do I hijack that? Well, what happens if the router, which is my little grey box, doesn't pass your data on, but pretends to be you, right? So it says, you go, give me data, and it goes, thank you very much. I can do bad things with your data, right? I can pass it on, I can give it back, right? Because it's HTTP, it's unencrypted. Therefore, you've handed your HTTP unencrypted data to an untrusted, unknown third party, i.e. my little router on the wall, right? If you put HTTPS in there, then there's some handshaking going on between the browser and the website, which is great. And after that, you go, I have a secure two-way encryption, and that's what we're all expecting to happen, right? And to be honest, if you go to websites that are not HTTPS, wherever you do it, be suspicious, right? Everybody is trying to get rid of all of those. We want to go HTTPS because of the security that it gives us, right? But even so, because of your behavior, I can break this too. I can get you to accept the certificate. And all I've got to do is get you to accept a certificate of mine, and then I can spoof you in most other places. So what happens here is I've got my browser talking to the router, talking to the website. The router is having a secure conversation with you and having a secure conversation with the server you're trying to talk to, right? So when you think your data's going encrypted, it is, but it's only going as far as the gateway, which is you're having the conversation with, not what you think. So now he's got your data, he does whatever he wants, and he can pass it on to the web server so you don't know, but there we go. 2 sets of secure communication. You think you're okay, but you're not really, right? In that case, you saw it, you accepted it, right? But let's try another one. You may have a browser that's mandated by your company, right? Or you may have been hacked, and I may have now put a certificate authority into your browser, right? And when I say browser, think other places that you have certificates. Once it's in there, then whatever you do is compromised, and you'll never see it, right? The scary thing is that the certificates that are in here, which come from, which are shipped by Chrome or Firefox or IE, all those certificates are all supposed to be managed and it's supposed to be secure, but you can always get an extra one in, and if one of them is invalidated, right, if the provider of that certificate is invalidated, you may never find out because the process of removing it is difficult and doesn't work very well, right? So, I think we're okay. So, right. And then there's one more attack, so I won't do the words because we're running out of time. So, let me give you a picture. HTTP is bad. HTTP pad is bad because, imagine this. If the first connection you make to a server is HTTP, it is in the clear. So if that website sends you back an HTTP page that includes links to signing on, which is quite common, that link will probably be HTTPS, which is what you'd expect it to be. Because I can manipulate the data that you get and you can't tell, I can replace the HTTPS secure website link with an HTTP one. Right? So what happens then is you go, see the front door, press the login, get a page up, type the detail in the post, type the details, press the button, right? Now, the guy in the middle can't make a secure connection to the server because he hasn't got your details. But what he can do is because you've just given him in clear your password and your user ID and password, he can steal that away, and then he can tell you that the server's temporarily unavailable. And you press refresh, and he gets out the way, and you're back, you signed in, but he's got your details, right? Another common way for people to steal information from you, right? And believe me, these protocols, right, the big banks, the online guys, the HT, whether it's Amazon or whatever, those protocols, the flow between the server and client is well mapped out by the cybercrime guys. They're going to target you, right, on these sorts of places. So, what can I say? If you don't have a VPN, if you're not using a VPN right now that gets you to a gateway that you can go out to the internet that you trust, you are vulnerable. Right? So you've seen these man-in-the-middle stuff. That's the browser piece. But think about everything else that you download, that you rely on to have that sort of conversation. Right? It could be ISOs, it could be RPMs. Anything that comes down could be corrupted, could be changed. Right? So unless you understand how it's working and you can prove it, how will you know? Right? Yeah, and of course, as I said before, we just turn stuff off because it's easier. Right? I love I thought I was using the tool correctly. These are real quotes from people about why things went bad. Someone changed the script and I didn't know why. Right? That's a good reason for you to put your scripts under change control if you don't already. Right. So, you have to think of this like this. So, you saw what you could do with the browser. The browser guys are trying to make that harder, but we as a developer community work against them by turning stuff off. Things that we do to make our life easier makes the cybercrime guys' life easier. That's the bottom line. So you have to question everything that you're doing and going, why am I doing this? Why am I opening the doors? Why can't I keep them small, right? And people don't test. People don't test security, which is not surprising because you don't pay much attention to it. But you have to think about what are you going to do to build testing, right? So one of the things to go read about and understand is things like pen testing, penetration testing. Go see how they get into your system, right? Right. Yeah, so I think I talked about that. Yeah, we did that one. Don't download or depend on random code. That's true. If you do need to use other people's code, then think about taking your own copies of them so that they don't get changed dynamically, right? If your application has some nice little JavaScript front end and you've got some web pages that have got referred to CDN or whatever, all of those could be changed. And in which case you could be running code that comes from somewhere else. So if you're serious about security, look hard at the code that you depend on and make sure that you serve up your own copies, not random ones from the web. Right. Right. So, what can I say? With great power comes great responsibility. I need you to take this seriously. We are the people that have to change, right? You've got to learn what you have to do to make the changes. Now, I'd say we're really bad at doing this because we like to have a nice, easy life. But we all need to be looking at how we change our behavior and how we assess the tools we're using and how we understand the risks we're taking by not taking it seriously, right? I want you guys to come to the rescue, right? I want you to learn how authentication works because you rely on it so much and most of you don't know how it works, right? I want you to think more about your blind trust. Why do you trust people, right? And this is all hard. This is not Java. This is us as a community, right? So I have other sets of snippets, but I think we'll run through those. Hacking your own systems is a good job. It's worth doing. Getting into the habit of understanding how the bad guys come through. If you can get your company to do that, that would be really good. And think about why you have blanket God mode. Do you need root access, right? Would you have one key for your house, right? And would you give it to your neighbors, and would you never ask for it back? Okay. Why would you do this, right? Why would you give your colleagues power of attorney over you? Because that's what you do. You share things way that you shouldn't do, right? Why would you deploy a server application with default passwords unchanged? Well, because it's easy and I'll change them later. And if you do things like that I think it's been before, on the web, public access, if you create a server, an IP address, it will be noticed within 15 minutes and it will be hacked. And a hack attempt will take place within 40 minutes. And if you've got default passwords, right, then you're done because they'll be in that quickly. And it happens all the time. All right? And normally I do these sort of talks and afterwards people come and say to me, I did this or I heard this and this happened to me. There's always stories. So do really take this seriously. Right? Put it in terms of what you would do with your own home security. You wouldn't have a home security system that you didn't know how it worked. Right? But for some reason, as developers, we're happy to do that with development tooling. We're happy not to worry about how things work. So I think, to round this off, it's time that we put the S back into developer. I'd like you to become super developers, right? And I'd like you to walk away from here, right, learning a couple of things. I'd like you to go away and understand that before you write that secure application, which you know you've got to do, that you start focusing on something really simple. Learn how you build and deploy one. Look at the DevOps tooling, get your head around those, understand how that works. That will lead you to understanding what problems you're trying to deal with and how you're going to deal with it. Once you've got that bit sorted, then doing secure applications is easy. Okay, and that's it. Thank you very much.